Alright, so last chapter we learned how to graph sine and cosine functions, and so this chapter we're going to do the rest of them. Tangent, cotangent, secant, and cosecant. So we're going to start with tangent, and so we'll see the graph here of tangent. And so some important things to take away here that are slightly different than sine and cosine. The period is pi, alright, and look at the difference in the shape of the graph here. And so we've got some new things here, most notably the asymptotes. And you'll notice here, if we go to our unit circle, remembering that tangent of theta is y over x, what happens when x is 0? We're going to be undefined for tangent. And so x is 0 at pi over 2, at 3 pi over 2, at negative pi over 2, 90 degrees, 270 degrees, all those places where we're on the y-axis. So all those places we're going to have asymptotes, and then if we look at this, erase this, similar to how we graphed the sine and cosine functions in terms of 5 important points. We still have those 5 important points. One of them is the asymptote. The second one is the asymptote. Okay? The third point is our central point, kind of the origin of our one-period tangent curve. And then we're going to have 2 more halfway in between the asymptote and that origin point. Okay? And so that point for tangent starts low and finishes high, and the height of those will still be the amplitude, that number that goes in front of the tangent. So with that, we should have enough information to try to graph some of these. Let's try this. Let's go ahead and try to graph y equals tangent of x over 2. So right away, I'm going to look for the number in front of tan. That's 1. So I know my amplitude is 1. My period normally would be pi, but I need to divide by b. And b is this number in with x. And so if we think of this as 1/2 x, then we're going to say pi divided by 1/2, or pi over 1 times 2 over 1, so we'll get a period of 2 pi. That's all the information we need to graph one period of tangent, because there's no shifting going on. If we look back to the original function, no plus or minusing anywhere in here. So first things we're going to do is we're going to figure out where our asymptotes are. And so the asymptotes for a tangent function, let me flip back real quick here and look at our graph. Notice that from asymptote to asymptote is our entire period of pi. But since it's centered on 0, half of the period is going to be on the positive side, and half will be on the negative. And so our asymptote, if there's no shifting, will be located at half of the period. So if our period was 2 pi, then our asymptote will be at pi. The other one will be at negative pi. So we've got ourselves our 2 asymptotes. No shifting, so we go to the origin. Amplitude of 1, go down negative 1. And so halfway in between, our 4th and 5th points would be negative pi over 2 and pi over 2. And those dots would be at the amplitude of 1. Our graph gets sucked towards the asymptotes and then turned in. That is a horrible drawing of this. Let me redo that. Here's our dots. We have arrows down at the bottom and at the top. There we go. That's a little bit better. Okay, so we're going to go steep, and then we're going to flatten out in between our 3 internal points. See if you can do it yourself for 15. All right, here we go. Our period on this one is pi, because there's just a 1 inside here. Our amplitude is 1/3. So we'll go ahead and say pi over 2. Remember, half of the period. And negative pi over 2. Let's get some asymptotes going here. No shifting. So we're at the center. And so our important points will be pi over 4, plus and minus. Amplitude of 1/3 and negative 1/3. And up we go.